to show you how to generate a calibration curve in Excel like this one that we did in lab. And so that's what I'm going to do here. So this is the kind of thing that we're trying to make. We want it to be nice and clean. By clean, I mean I don't want clutter here that makes it hard to read and understand and interpret what's in the curve. But let's talk about what the curve actually tells us. Notice that basically what we have is a set of data, and we have the readings from our instrument on the x-axis, and we have the known true values of the data on the y-axis. And so what this does is it generates a function. Here's the function, y equals mx plus b. This happens to be linear. And we use this function to convert readings from our instrument into the actual readings of the wavelength, in this case, for our spectrometer. And so then we can use that for unknown data. So this calibration curve is generated for something that we know, and then we use it for something that we don't know. So here I have the calibration curve. This is the known data that I was using. And here we have the unknown data. So in other words, I took some kind of line spectra whose lines I was sure of: 446, 468, 501, 588, 669. This happens to be the line spectra of, I believe, mercury. I can't remember off the top of my head, but I think it's mercury. And these are the numbers that I actually get from the spectrometer itself. So when I look through the spectrometer, I see that grading. Here are the numbers that I read off of that grading. Okay, and so I generated this function, this curve, this calibration curve, of the x values here versus these y values, and this is the equation that it gave me. Now I can take this equation and apply it to anything. So this might be my data from, for instance, the fluorescent lamps. So I look at the fluorescent lighting and I see a line at 4.2, a line at 4.8, a line at 5.1, and a line at 6.4. I want to know what the actual wavelengths are of those lines, and so these are the numbers that I get out of this function. So these are the corrected values. These are the calibrated, corrected values for the uncalibrated or incorrect values that I get directly from the spectrometer itself. So let's see how we do this. So again, everything's nice and clean, easy to read. I'll show you how to make this. So I'm going to go ahead and delete this. I'm also going to go ahead and delete this data. Clear all. And let's see how we actually do this. So the first thing that you need to have is you need to have your scale reading, or however you want to label this. This needs to be in a column of data, and the first column of data you select is going to be your x-axis, and then you have to have your calculated wavelengths on the y-axis. So for you guys, you should have 3 scale readings from hydrogen and 3 calculated wavelengths from hydrogen. So you're going to take your scale readings as being the uncorrected, uncalibrated value, and your calculated or theoretical numbers as your calibrated, or excuse me, as your actual value. And we're going to generate a calibration curve that converts from our scale reading to a real number. Okay, so the way that we do that is we grab and select the entire set of data. I see that this is not highlighted. This is kind of an eccentricity of Excel. Everything inside of the green box is actually highlighted. It leaves the original cell that you clicked unshaded. I'm not sure exactly why it does that. I'm sure Microsoft has a good reason for doing things this way, but all of this data is actually selected right now. Okay, so then I go to Insert, and there are lots of different kinds of charts that I can insert. But in the sciences, we generally almost always use what's called an XY scatter plot, or Excel just calls it scatter plot now, and it's just the dots of the data. I want to put in any of these curves or any of these circles or any of this kind of weird stuff. If that's something that I want on my graph, I want to generate it myself and not have Excel do it automatically for me. I just want Excel to put in the actual dots of data. So here they are, here are the dots of data. So our job is to turn this graph into something that actually looks nice. So that's what we're going to do. Now some of the steps that we're going to do here are going to be unnecessary. There are things that are just personal taste. And then there are some things that you absolutely have to do. So I'm going to go through what you absolutely have to have is a chart title. You have to have titles on your axes. You have to have the correct scale values. and you have to have a trend line added with an equation. Everything else is optional. But the first thing I'm going to do, notice that there are lots of different places I can select in here. I can select the chart title, I can select kind of the entire chart, I can select the grid lines, I can select the plot area, I can select axes. So it's kind of, you have to be careful that you're selecting what you mean to when you're working with a chart in Excel. Well, what I'm going to do is kind of click right on the outline, and that just ensures that I've got the entire chart selected. And now that I've got the entire chart selected, I'm going to go back to Home, and this will just allow me to quickly change my font size, which I'm going to change to, let's try 16. 16 is nice. It's nice and big and easy to read, so this is something that I like. I'm also going to make this quite a bit larger. It did not want to do that, so let's try this again. There we go. Nice, big, very legible chart. The next thing is, I personally like to get rid of these lines, so I just click on one of them and notice that we have these little dots indicating that that's what I actually have selected right now, and I hit delete or backspace and that gets rid of them. And I click on these lines and do the same thing. And I like to do that because, to me, having the lines on there makes it look like graphing paper, and I don't think that that's very nice looking chart. So I like to have a clean looking chart like this. Next, here's my data. Notice all of my data is in this upper quadrant here. The rest of this bottom right hand quadrant and the entire left hand side of this graph is empty. So there's no reason for me to show this empty stuff. I want to adjust my scale on the bottom and adjust my scale on the left here, the vertical and horizontal axes, so that I'm only looking at this portion of the graph, because that is where all of my information actually is. So to do that, you right click on your data and hit Format Axis. Now what's going to pop up is you're going to get a Format Axis box over here. There are lots of things you can choose to do here. For instance, Text Options allows you to change what the actual text looks like inside of here. I don't care about that, it looks fine to me. When I go to Axis Options, there are lots of different things I can choose here as well. So I might be able to, this little paint bucket will allow me to, for instance, change the color of this axis if I want to. Again, I'm happy with the way the axis looks, so I'm not going to do that. This one that looks like a set of graphs is called Axis Options, and this is the one that I'm actually interested in. It gives me the opportunity to change the bounds, which is what's the smallest number I want displayed here and what's the largest number I want displayed here. Right now it's displaying 0 to 800, but the visible range is only 400 to 700. So since we're dealing with visible observations of visible light, then 400 nanometers to 700 nanometers are what I need to use. So I'm going to come over here, click minimum, type in 400 and hit enter. Now if you'll notice, this automatically changed to 700, but you see how this is an available button now and this is not? This is still actually set to auto. So Excel guesses that I want this to be 700 and it puts it at 700. Now as I start to change other things about the graph, as I change what the axis is down here, I maybe change some of the other parameters that I'm moving, Excel might change its mind and decide that I actually want this to be 600 or 800 or 1000, and it'll start scaling this. So even though right now it is reading 400 to 700 and that's what I want to ensure that that remains constant. So I'm going to click this, type in 700 and hit enter. And now it's actually locked at 700. See how this button now is available for me to push? It says reset. I can reset this back so it will do things automatically like it is here, or leave them at 400 and 700. Again, hitting enter to make sure that they're locked in. Alright, I'm going to close that. And then do the same thing down here at the bottom. Right click, Format Axis. It's going to pop up over here. And now my minimum, I'm going to make 4 because that was the smallest number on the scale I used in the spectrometer. And the maximum, I'm going to make 7 because that was the largest number. So now my scale reads exactly what I want it to. It reads 400 to 700 nanometers, and it reads 4 to 7 on the horizontal axis. And notice that my data now fills up this entire chart, which is exactly what I want. I'm not super happy with these little blue dots. So this next thing that I'm doing is optional. But I personally would prefer to get rid of these or change these blue dots. So I'm going to right click on one of them and hit Format Data Series. And what will pop up over here after a little bit of time is, again, the Format Data Series. Again, I have some different options. I can change, this is like a special effects button. I can put shadows under them, make them glow, make them look three-dimensional. I don't want to do any of that. I'm actually going to go here. I have two options. Marker is the kind of style that it is. Right now it's a circle, which I'm fine with. I want it to be a circle, but I want it to be a larger circle that I can actually see. So I'm going to change that to 10. And you'll notice that after a couple seconds here, the size will actually get a lot larger. Actually, I have to hit enter first, but there you go. So now that's a nicer circle. I still am not pleased with it because I don't like the blue. So what I'm going to actually do is no fills. So the circle is not going to have anything inside of it. So I'm going to click no fill. That will clear this out. And then the border, I do want a border, so I'm going to change the border to a solid line. And I want to change that to black. And again, this is personal preference. This is not something that you have to do. This is something that I like doing. But that's basically it. And you can play around with this and get it to the way that you want it to be. Now, line is a connect the dots. You can force it to put a line between the dots. We don't want to do that because that really, it literally means nothing. There's no scientific meaning. It's just, imagine that someone just comes by with a pin and puts a line connecting each of the dots. No meaning whatsoever. So if I put something like solid line, it's just going to put a connect the dot type line in there, and that's no good. So I don't want that. I'm going to leave that off. Okay. So let's see what we have so far. Things look much better. So the next thing that is required is to put a chart title and axes titles on. Now I've already got the chart title here, and I could just double click in here, select it, and name it calibration curve. And that works fine. You can do that, and it looks great. But if for some reason I need to change the name of my data, at this point, if I have to change the name of the data or the name of the chart, I will have to change it twice. I'll have to change it over here where the data is, and this is just to keep things looking nice. I would have to change it here and here. So instead, what I can do is if I click this text box and then go up here to this f of x bar, this is called the formula bar in Excel. And basically what this says is I've clicked the box, and now what this says is I want that box to equal, and I can make it equal anything. I can type in here, for instance, 7 times 3 and hit enter. Oh, I'm sorry, that did not actually work. I've never tried that before, but I guess that won't work. So let's not do that. I think something like I could put in parentheses calibration curve 2. There we go. So I can actually type up here what I want it to say, but I don't actually want to do that. Instead, what I want to do is come in here, hit the equal sign, and I'm going to pick this cell that contains the name that I want. So I'm going to click on that. Notice it says sheet 2. This is the second sheet in my Excel file. Sheet 2. This is column A and cell 1. So it says I want you to print in this box whatever is in column A, cell 1. Okay? And then I hit enter. And so whatever is in this box here, A1, appears up here. And so I could, if I wanted to, again, I could call this calibration curve 2. And after a few seconds, it will update automatically. So I like doing this because then I can just change everything I want to in the actual spreadsheet here, and it will automatically update my chart without ever having to change the chart again. So I'm going to go back here and remove the 2, and it will update itself. Okay, I'm going to select the chart, come up to chart design, and add chart element. Now everything that I would want to add to this chart is here. Like for instance, if I accidentally deleted the title here, I could add the chart title back. Okay. Instead, what I'm going to do now is add an axis title because I want axis title. So primary horizontal, there it is, it pops up at the bottom. Again, I could just double click in here and type in what I want to, but instead I'm going to go to the formula bar, hit an equal sign, and then I want my x-axis to be scale reading, so I'm going to click that and hit enter, and again, now it just displays whatever is in this cell. Alright, one more, chart design, add chart element, axis titles. Now we're going to do the vertical axis, okay? Equals, and I want it to equal this one. Now, unfortunately, this is one of the things where Excel's not super smart. You notice that I have this formatted the way that I want it with the actual Greek symbol lambda for wavelength here and the Guggenheim notation, which says that this axis is equal to whatever my wavelength is divided by the units of nanometers. So we talked about that on the first day of lab. If that doesn't make sense to you, you need to go back and review the end of chapter 1 to understand the Guggenheim notation. But this basically just says that, for instance, this is about 450 nanometers. That's what the units there mean. But I want this L, which is just an L, to actually be a Greek lambda sign. So the way that I'm going to do that is if I right click in here, I can hit edit text. And then what I'm going to do is just hit shift and up. So I select the L, right click in there and hit font. Now the font that gives these Greek symbols is called Symbol. That's a standard font. It's on all computers, Macintosh and Windows. And it converts the English letter into the Greek letter. So L is the English letter, lambda is the Greek letter. So when I hit OK, it's going to convert that to lambda. So now we have a really, really nice looking chart. There's a title on each of our axes. This is exactly what we want for this particular chart. The last thing is I need to put a trend line in here. So I'm going to right click on any of my data points and hit add trend line. Now what comes up is a bunch of stuff. Different possible trend lines. So we could treat this as an exponential function. Notice how it puts a little bit of a curve in here. We could treat this as a logarithmic function. It puts kind of the opposite curve. We can treat it as a power series. But this is linear data, so we want to actually have a linear function here. Okay, so we click linear, and in fact, when you add a trend line, it defaults to linear because very often we attempt to find linear relationships between things in the sciences. So we have linear. Now notice that this line only extends from my first data point to my last data point. I would like for it to extend further and further forward and further back. That's called forecasting. So if you'll notice down here it says forecast forward. Basically I want to forecast forward from this last unit to the edge of the graph. So I'm just going to put a 1 there and hit enter, and you'll notice that what it did was it spread things, it pushed the trend line out a little bit farther. Backwards, same thing by 1 unit, and there it pushes the trend line down. And so now we have a very nice looking trend line here. Again, if I want to, I can mess with some things to make it look different. So to make it really legible, what I might do is change it to a solid line. Again, dark to make it print a little bit better on a black and white printer, as most of you are. I'm going to actually change just for fun. Somewhere in here we should have dash type, and so we can either make it a straight line like this or a dashed line like this. I think that this one is the easiest one to see. So we can see clearly how the trend line and the data are not exactly the same, but this is the best fit line that goes through the data points as evenly as possible for all of them. Okay? Excuse me. All right, then I go back to my options here. The last thing is I want to display the equation on the chart, and I want to display the r-squared value on the chart. So I can move this around, and now we have a very, very nice looking piece of graph that we can print and turn in with our lab report. Okay, so how do we use this? this equation says that you take whatever's on your x-axis, you multiply it by 100.58 and subtract 24.846, and you'll get the number that's on the y-axis or the vertical axis. So that's what this function does, is it takes a number from the x-axis and maps it onto the y-axis. It's the y-axis is a function here of whatever is on the x-axis. So here is a set of unknown data, and I could physically do this. I could physically come in and plot 4.2 and see what my number is. It's actually below here, so it would be hard to see. Or I could plot 5.1, so 5.1 would be about here, and we would go up, hit the function, and move across, and we would get a number here. Now, doing it visually like that, there's a lot of error, potential error that you could have. Instead, we're going to use the equation itself, because the equation is the equation of this line. It is the equation that maps these two sets of numbers together. So I come over here. This is, again, my scale reading. This is my lambda, and this is my a function of x. This is a function of scale reading. So what I'm going to do here is I'm just going to type in this equation. I want whatever is in this block to equal. So this block is y. This cell right here is y. I want this to equal 100.58 times. Times is the Shift 8 button in Excel. A multiplication symbol is the asterisk. So Shift 8. And then what do I want my x to be? Well, x is this number. This is x. So I'm going to click that. Notice it says A13. So what this is saying is I am telling Excel, I want you to print in this cell 100.58 times whatever is in A13 minus 24.846. Enter. So this is what I would get if I plugged 4.2 into this equation. 4.2 into this equation, and that is exactly what I would get. Okay? Now here's the beautiful thing about Excel. If you were doing this with a calculator, you would have to do this 3 more times, and I would just have to plug things in 3 more times. With Excel, this little bottom corner symbol here, this little box, if you click on that and drag down, what this says is to do the same thing in these 3 cells as you did in this cell. So I'm telling Excel, do the exact same thing in these 3 cells as you did in this top cell. So if I look at them, you can actually see what the formula bar says. It says 100.58 times A14 now, because it wants to use this cell. If I click down, it's 100.58 times A15. So it just takes whatever's in the cell next to it and does the exact same thing that I did up here. Okay. Now, last thing is I've got too many significant figures here, too many digits. So what I'm actually going to do is just make this smaller. These buttons up here, it doesn't change the number. It doesn't actually round it. It just tells Excel to hide the extra digits. So I'm just going to do this to remove the decimal places, and now Excel is giving me a nice looking chart. So this says that even though when I looked at the fluorescent lamp I read 4.8 on my scale, the correct number there was actually 458. So I should interpret the 4.8 as being 458 nanometers. And that's what a calibration curve does. It takes an uncalibrated set of data and converts it to the correct values by calibration. If you have any questions, please don't hesitate to shoot me an email. I'll be glad to help as much as I can. But